Okay, now members, welcome to today's lesson. Today we are going to see how do we use the logarithms we've seen, the anti-logarithm, how do we read the table to solve such equations. These equations can take 6 to 12 marks depending on the composition. Okay, let us see. Use logarithm to evaluate the following. Now they give you this. What you do, this one is that you have a composition of a product up and a product down. Then after this product divides this product, so you have to be careful there. What do? You first deal with the upper product, then you write 1.8 this, and then also this. Then you convert them to a standard form. How do you convert the standard form? It should be between 1 and 10, the digit after. I mean the digit before the decimal point should be between 1 and 10. You see this is beyond the 10, so if we shift it here, we get now 1.82. Now if we shift it to the left, the power becomes positive. And then this power indicates the number of places we have moved that decimal point. So this one I have moved it 1 decimal place. So that's why this is 1. It's positive because we are moving to the left. If we are moving to the left, it becomes positive. Then when you read this will be, then write this power on the 10 here. Then after, you read off this in the table. How do we read it off? You read 1.82 under the table as we are going to see. So get your log tables and I show you how I read that. Now, you see that we are reading 1.82. So you come in your log tables. We say that these values here at 1 decimal. So this is 0.043. Then these ones, they are like that. So they are missing decimal points here. Then I'm reading 1.8. So these ones are not 10, 1.0, 1.1, 1.2. Okay, so I'm reading now 1.8 under 2. So 1.8 under 2 is under 2. This is the value 1.8 under 2. So 1.8 is here. My under 2 is here. I think the value we get is 0.601. So here they are missing 0 points. So that's why I have the other one plus this now 0.2601. So now this one on the 10 plus what we have read as 0.261. When you add this, that's when you come to this value. Then the same here. Now we start this one. It's not in the standard form because we say the decimal point, the figure before the decimal point should be between 1 and 10. So to make it this, so we shift it here. So this would be 3, then this would be 3.1. But because we are moving to the right, the power becomes a negative. We have moved the 1. That's why we have the negative 1. Then this negative write it as 1 bar. Then read off this from the table as you are going to see. So you are reading, I'm going to read now 3.1. So it means it has under 0. Then you come, this is my table. I think we see 3 where 3.1 is. This is 3.1. Under 0, this is the value 4914. But we say this is 0.4914. Then we add to the other bar. So this is what we have. After reading this, we go to this. Then you add this negative. When you add this and this, that's how we are coming about that. Then after, remember we are multiplying. If we are multiplying the logarithms, we are multiplying this. It means we add. When you add this, you get this. When you add this, you get this. This, you get that. And then 1 plus a negative. This is negative. A bar means a negative. So 1 plus negative 1, you get 0. Then you condense this. So meaning now you know the value for the upper part. You come to the downer part. You have this times this, converting it to, now you see a constant to it here, that's why it's negative. This one is already in the standard form, so we are not moving any place, that's why I have 0. So 0, then we read this from the table, you get 0.236. Then this one, we read 6.2 from the table. Now the table you are reading in is the table which is having logarithms. This table, it has logarithm here. That's what we are reading from. So see the value we are reading there is 4.2. 4.2 is here. You see it's 612. Yeah, 4.2 and 6.232. under 0. You see that this is 4.2 under 0. So, because this one is having 0, any number you can put here 0. So that's why we are reading this. Then when you add this, you get this. When you add, now look here. When we add 9 plus this, you get 11. You carry 1. When you add this, you get 14. Then you carry 1. This one is positive. When you add it to a negative 1, we get 0. 0 plus this, that's how we are getting a 0 there. Then after, now I put the product down. So this and this is giving me this. But remember, I'm dividing this by this. So if we are dividing logarithm, it means we are subtracting. So then I get this, I subtract off. I get now this, the one which is up, then minus this one which is down. Because in logarithm, if we are dividing, it means we are subtracting before. So this minus this we borrow. Then when we subtract this is what we are adding like that. As simple as that. Now, after doing this, now the value of this is going to be the antilog of the value we have got after simplifying everything. So the antilog of this is 10 power this. Now let us see how we read there. Now this one, you go in a book, on a page where we have antilog, you read it carefully. So see that we are reading the book where we have the antilog, as you see here, antilog. So 10 power x, this x are the values here. So see that we are reading 3, 3, 5, 9. So 0.33, you see 0.33 is here. 0.33 is there. Then that 0.33, let me cover so that you can see properly. Okay, what I'm reading is now 0.33, so I'm going to use this, all this. So what is the figure we are reading? 0.3359. So this is the figure we are reading. So 3.3 here is the first here. I think you see. Then under 5. So under 5, you see under 5, it's here. So we have under 5, we have 2, 1, 5, 8. So this is what we have under 5. But they are telling us we go and we add under 9. So now when we come to this table under 9, you see our under 9 is here. So that we are adding a 4. When you add a 4, under 9, this is under 9. So we are adding a 4 here. When you add that 4, our 0.33, under 5 is this. Then we come under 9. Under 9 we are adding a 4. When I add a 4 here on this, when I add a 4 on this, I'll get 2, 6, 1, 2. 2, 6, 1, 2. I think you see in my antilog, this is what I get. 2, when I add a 4, this figure under 0. We are at 0.35. 0.3 is here. Under 5, it's here. You see this value is here. Sorry, this is 6, 2. It's 2163. So it's 2163. Sorry. The value under 5. The value under 5. This value under 5 here. Under 5 is 2.163. Then we are adding a 4. So we get this 4 under 9. We are adding a 4 in the same row. When we add here our 4, then this will be 2167. So now this 2167, but now these values for anti-logarithm, for them they are to 1 point. This is 1.022. This is now 1.389. So when I get this value, now this will be 2.167. And after getting that, this is how you get to that value, 2.16. Now I mean the all of this is this. When you press that on the calculator, that should be giving you a value equals to that. Okay, now we are going to try this as an exercise. It has a root, a cube root. Now, if it has a cube root, let us handle the one for a square root, then you will be able to handle this. The same value now, we put these ones under this. I think you know how now we read these ones. The same now, we are multiplying the upper part. If we are multiplying now, we add. When we add it, negative 1 plus 2, we get this plus this, we get that, and so on like that. Then down, we have this times this. Now you must convert these two as significant, the standard form. We are going to do this 1, 2. That's why I have 2, because I'm going to the left. Then this will be this. Then if I'm writing, now I write 2 first. This 2 then on the power first. Then I go in the table and I read off this 5.3 under 4. This is the figure we got, 0.72575. Then we add 2 to get that. Then when I come to this, I have now to shift it 1, 2, 3. But I'm going to the right. That's why I'm having the negative. Then it's here. Negative. Then write this one, and then I write it as a bar. So 3 bar. Then you read 1.3 in your log table. It will give you 113. Then the point. Then we add this plus what we have read from the table. Then when you add these ones, that's what you get there. Then I know now the value for the upper thing and the lower thing. So now we get this. The whole of this is giving us this, and the whole of this is giving us this. Then we get this divided by this. But in logarithm, if we are dividing, it means we are going to subtract. That's why I am subtracting now. So this would be this time minus 5 minus 4, I get 1. 5 minus 1, I get 4. 7 minus 5, I get 3. Then 5 minus 8 is possible. So I borrow here 1. If I borrow here 1, now here I'm dealing with 0. When I take here 1, I have now 15 minus 8, which will give me a 7. So here I have now I read with 0 because I borrowed this. I have 0 minus 1, which will give me positive 1. You have to be careful with the characteristic which is negative. Then this will be this. Then I need minus by the square root. The square root of this means that it's a half. The square root of a number is a half. So that's why when I have that, it will be the same as, whenever I have a square root always, it will be the same as a half. Square root of a, the same as a power a half. When you have a cube root of a, the same as a power a third. That's why now my power is a half. Now when you introduce this power, the power is a half, you just multiply with this power. If it's a cube root, like on this number, now here we have multiplied with a third. We multiply this with a half. Now, the figure you get, you should give it to 4 significant figures. In logarithms, we deal with 4 significant figures. So with this one will be, when you divide, you get 0.86705. But to 4 significant figure, you round off. That's why we are getting this one there. Then after that, you just come and read the antilog of now this. The antilog of this, I think you know how we are reading it now. You read 0.86 under 7, then you add a figure under 1. This is what you get. It means that now the square root of the whole of this is equal to that. So that's how we use logarithms, members. I wish you well.